Friendly greetings and welcome to the Multirotor Mania OSO Race Edition Let's Build. In this video we will build out this racing quadcopter from a pile of parts. A full parts list can be found in the video description below. Thank you to Multirotor Mania for sending me this kit to build out and to create a video. Let's build! So now that we have everything laid out in front of us, we can start with our power distribution board. And to do that, we're going to take our servo pins. And these servo pins are made for regular servo leads to plug into, but we're going to use them to hard mount our equipment to our power distribution board. We're going to need to break off a few sections to use. 4 of them 3 long, 1 of them 2 long, and another one 4 long. Please note I use a lot of sped up footage, and at any point in time you can pause the video for a very clear image of what I'm doing. And once these are cut out, we're going to dry mount it to our frame. Our OSD goes in the middle, our Pololu 5V goes next to it, and our 12V goes at the end. The reason I dry mount everything is just to double check that all the connections are in the right place before I start soldering, and that everything is where it should be. Now we need to take off all the parts so we can solder on our servo header pins. With my Let's Build videos, I use a lot of sped up footage. This is to condense it down into a reasonable time frame. At any point in time, you can pause the video to get a better look, which I highly recommend you do, especially since there's a lot of little connections on this power distribution board in this video, and it can be very confusing at times. Later on in the video, I have a completed shot of the power distribution board, so if you get lost, don't fret. I've also provided links in the video description to images and other videos on how to put this power distribution board together. Okay, so now that we have our header pins soldered on, we can start attaching our 5V Pololu. Now make sure you line up the connections to the positive and negative and the voltage in and voltage out. Once you have that in place, we can move on to the 12V Pololu regulator. And it's the same thing. Remember to match up the 12V in and 12V out and the ground. Remember to not mix these up, as there could be magic smoke. And for whatever reason, if you do blow out the 12V regulator, you can just jump the 12V in and the 12V out and have direct 4S power go to your video equipment that will be filtered through the ferrite ring and capacitor that we're going to add later on in this video. Cool, so now let's put on our OSD. We're going to use a piece of tape to secure it onto our board while we solder it. As you can see, there are several connections that we have to hit with our soldering iron to secure it to the board. Now you notice I use liquid flux, but I recommend using paste flux for this process. Now we have to solder the OSD to the pins that are connected to the board. You have to hit the TX, RX, 5V and ground, the battery in, and then the video pins. And there you have the initial first part of our PDB build. Now we have to add a few little items to filter our power and a buzzer. So this is our buzzer. It's a lost model alarm, and we have a capacitor, smooth power, and we have a ferrite ring, which will also smooth power. Attaching these to our power distribution board is fairly straightforward and simple. So our capacitor goes in between the 2 Pololus in the circle with the positive and negative connection showing. The capacitor will help filter power going into our video and coming out to our video transmitter. Along with the capacitor for smoothing our video power, we have our ferrite ring. And we're going to attach this first, and it really doesn't matter which way it goes, just make sure that it goes into the right holes. The ferrite ring acts as an inductor that the power passes through and smooths out as it moves over a magnetic core. This creates its own magnetic field that helps smooth the power out as it passes through the copper wound wire. Now we need to add our capacitor. The capacitor acts as another power smoothing option. It holds a little bit of a charge and it discharges at a set rate. So it helps smooth out the power in pulses. So the pulses get sent out and the inductor smooths out the pulses. With the two of them together, you end up with a very comprehensive power smoothing solution. And power smoothing is very important as the ESCs generate a lot of spikes in the amps, which can cause video artifacting and sometimes can blow out your video equipment. So it's always a good idea to use a ferrite ring and capacitor. With our nearly completed power distribution board, we have our Pololus, our capacitor and ferrite ring, and now we have our OSD installed, and our OSD comes out there. We haven't added pins for that yet. And next to that we have our 12 volt out for our video transmitter. It's starting to look like a monolith of a board. We have quite a few things attached to it, and we're going to add a couple more. So for our OSD, which I haven't fully supported yet because I had issues, but I'm going to show you how to install it anyways. We have more header pins. So you're going to break off 2 sections of 4, and we're going to solder these into place. Now we have the TX, RX, 5 volt, and ground coming off of these, along with, I think, another 5 volt and ground and our beeper pins. Now we need to attach our video harness to our power distribution board. So we're going to figure out the length that we need it at. And on this build, I decided to put the video transmitter in the back, again, like my previous one. And then I figure out the length I need for the cable to be, with a little bit of extra slack. Now we need to strip the wires. And once we get the wires stripped, we have to tin them up. Now, a word of warning, when you use rosin core solder, immediately when you touch the solder tip to your solder, you're going to burn away the rosin core, which defeats the purpose of using rosin core solder. So just like a word to the wise. And then once we have everything tinned, we're going to attach it to our board. And again, you might want to pause here to see exactly how the connections are set up. And once we have it soldered in, we're just going to twist them up and we're going to connect it to make sure it works. Cool, so with our power distribution board almost done, we can move on to our flight controller. The DragonFly 32 flight controller is slightly different than the NAS. It has a different pin layout with your serial connections, your OSD connections there, and your motor connection. We're going to take some right angle male header pins and we're going to cut them out and put them onto our board. Now I did a little trick where I took out 2 of the pins to fit into the board right. I think you'll see what I mean if you zoom in and you look closely. This process takes me in a minute because I had to redo it. Hopefully it's not too difficult to understand what I did there. And now we have to add 4 pins for our OSD and our 5 volt in. And now we have to add 3 pins for our PPM out to our receiver. And this is a little tricky, and hopefully you can follow along with what I do, but you might just have to kind of wing it. I'm going to cut out a single row of 90-degree angle pins, and then I'm going to angle those 90 degrees so I have signal, ground, and power going into the receiver. Now that I have all these pins dry fit, I'm going to use a little bit of tape to secure them down while I solder it to the board. Add a little bit of flux and solder, and it should be a few simple connections. It's always easiest to get 1 or 2 of the pins soldered and then move on to the other ones. And it's pretty straightforward and easy to do, especially when you have flux. It just tends to sip into the holes and fill in all the gaps. So I highly recommend using flux for this process. And again, you don't have to pre-tin anything at this point because you're trying to get everything into the holes. Cool. So now that we have our flight controller, we can finally move on to putting it onto our power distribution board. So we have our OSD connections, our receiver connection, and our motor connections. And now we're going to attach our LED. So this is an LED that came with the kit. It is a variable LED, so it has dip switches that you can change for colors. It's pretty bright. It runs on 12 volt, although I think it will also run on 14 volts for 4S. So one of the mistakes that I made on this build is I actually soldered my LED to the 12 volt out on my voltage reg. Now this LED pulls about 350 mAh at its lowest point. The voltage regulator is only able to put out 600 mAh. So if you do the math, with everything that the voltage regulator has to put out with, it's overloading the voltage reg. So as soon as I plugged it in, I had magic smoke. And this was because I plugged into the 12 volt instead of directly to the battery leads for my LED. So I would recommend, again, putting the LED directly to the battery terminals at the back of the frame instead of the 12 volts going out to your video transmitter. Again, do not do what I do. Do not monkey see, do not monkey do. I'm just illustrating what I did in failure. So, yeah. Once we have the LED connected, we are 90% done with our PDB, which is the majority of our build today. Okay, so now we have to attach our flight controller, and we're just going to secure it with the nylon nuts that come with it. And we're just going to hand tighten these. I've noticed that the vibration tends to not undo nylon on nylon, so take it with a grain of salt, but I've never had this come loose. And now we have our 90% done power distribution board with voltage regulation, OSD, flight controller, LEDs, video transmitter out, buzzer, the works. In this video, we're going to make our own battery cable. So what we're going to do is take 12 gauge wire, strip it down, and pre-tin it, which is going to take a lot of tin and a lot of power. So again, I recommend using a minimum 40 watt soldering iron for this part. Right now I'm using a 15 watt soldering iron, and as you can see, it's taking a lot of work just to get it heated up enough to sink in the solder into the joint. Again, using too little heat will lead to cold solder joints, which is really bad. But again, I double checked to make sure these were good. They were shiny, didn't look like there was any cold solder points, so I just went ahead with it. And again, this process would go a lot faster if you had a much more powerful soldering iron. And once you have it connected, we're going to add heat shrink over our connections, make it look all professional, heat it up, and we're going to cut it down to the length we need for our board. And once it's cut down, we're going to again strip them, and we're going to have to tin these. I'm going to tin the pads on the power distribution board, and we're just going to smother it in solder, get it nice and smothered, like a lot. And again, it pays off to have a higher rated soldering iron. So yeah, just going to make sure you smother it in solder. I can't say that enough. So yeah, once you have that, see this, it's not even working. I'm trying to get this to work and it doesn't even connect. So I switch it out for a 45 watt soldering iron set to about 30 watts. So about double the power of the other one. And as you see, it just melts on. And that nice shiny connection is what you're going to be looking for. Cool, so now we have that done. We're going to add a zip tie through one of the holes. This is to secure the wiring to the frame so you don't fray the connections too easily from pulling the battery out. So now let's start mounting our camera. Now you'll see there's holes on the frame for your camera to line up, so it's pretty easy to figure out where it goes. Once you've got that figured out, you have to find out how long you need the wires, and the wiring is convenient because there's 3 connections right next to where the camera goes. You have your ground, 12 volts, and you have your video connection. So we're just going to pre-tin, and we're going to just solder those on. With this connection, we are almost done with our power distribution board. The only thing left to do is to add a bridge on the bottom side of our power distribution board for our MinimOSD. And again, I'm not going to cover all of the MinimOSD because I've had issues with both of the ones that I've tried, so I can't finish a video on it. And so the bridge that you'll see, and again, this is covered in OSO Grande's build video, so if you're confused, please go and watch that. That'll cover all of the little connections. Once that is bridged, we'll take a closer look. Let's see here. See if I can get the camera to zoom in a bit more. So this is the close-up section. You can see all the little connections, everything is bent to the side, so there's nothing sticking out that will touch the carbon fiber. If any of these little blobs are too big and it touches the carbon fiber when you go to build the frame, you'll have a very bad day and smoke and fire. So just be aware of how long the connections stick out of the bottom of the board. On the top you can see a closer up view of the video connections, the Pololus, the ferrite ring and the capacitor. And in the back you can see the video transmitter connections, the buzzer, and the OSD pins that we soldered on earlier. Notice how the OSD is buried underneath the flight controller, and you have the OSD connections that will transfer there to there, and those pins will connect into our flight controller. So you have 5 volts, ground, TX, and RX. 5 volt ground, TX, and RX. 5 volt ground, TX, and RX. You may notice the servo connector that's going from the 5 volt to one of the motor leads. This is in case you don't have an OSD and you need to power your flight controller. It's pretty straightforward. But I would not use this connection if you have the OSD because then you'll just be redundant. So there you have it, the finished power distribution board, ready for the ESCs and motors. This is where I make a slightly huge mistake. So I attach the arms to the frame without realizing that I need to put the standoffs for the top plate on before I can put the arms on. And without realizing it, I continue on in the process of building the quadcopter, and I tighten down all of the lock nuts holding the arms to the frame. So later on in the video, I have to undo all of those connections to fix my problem and put in the standoffs to hold on the top plate, which holds our battery and our GoPro. So yeah, anyways, moving on, we can attach our motors to the frame. And if you're doing this, you can attach the motors individually to the arms before you put them onto the frame. And the same goes with the ESCs. You can attach the ESCs and motors to the arms. You can even solder the ESCs and motors together before you attach it to the frame. And I actually recommend you do that instead of do it the way I've done it. It'll save you some time, it'll save a little bit of hassle, and it's easier to work with. I'm going to skip ahead a little bit and finish up with attaching the motors to the arms, and I'm going to show you one of my favorite little tools in my workshop. So to attach the ESCs to the frame, I'm going to use a self-adhesive tape. This tape only sticks to itself and can be crumbled up and reused repeatedly, which makes it great for ESCs that need to be replaced. So now we're going to expose the ESC wires, and like the last build video I did, I'm just going to expose the tips of the soldering pads and leave the rest of the heat shrink on the ESCs for protection. I'm being fairly careful to not cut away any more than I need to. This is just out of precaution because I like having extra insulator between the ESC and the carbon fiber. I'm going to put an extra layer of insulation between the carbon fiber and the ESC, so there will be no chance of the ESC shorting out on the carbon fiber. Doing this and direct soldering your motors to your ESCs is the best option. The other way you can go about this is cutting the wires between the ESCs and the motors down and shortening them instead of unheat shrinking the motor leads and desoldering the motor wires like I'm doing now. The benefit of doing this is having one clean connection instead of having two. There's less resistance in the wire, so you have a clean, better connection. This can be important because sometimes you'll have a weak connection between the motor and the ESC, which will lead to weird problems where the motor will cog, as in you'll try to turn when you try to power it up, but it'll just kind of move back and forth. Okay, so now we're back to fixing my previous mistake. So I had to take off the back arms and loosen up the front ones so I could get the hardware in between the frame to put on the standoffs for the frame. Again, I recommend putting the standoffs onto the power distribution board before you attach it to the frame. This is just to make life easier, and again, do not follow my mistakes on this build, learn from them. Okay, so now we can prep our arms for the ESCs. I'm adding a layer of the self-adhesive tape onto the arms to insulate the ESCs from the carbon fiber. I'm cutting the strips to allow enough to wrap around the arms again to cover the ESCs when we're done soldering them to the motors. This tape is amazing stuff. I got it at my local hardware store, and it has the consistency of almost felt. I think it's called self-adhesive felt tape. There's a few brands online that sell it, and they're all a little bit different. So once we have all of our arms with the tape ready to go, we can then start soldering and cutting down the wires from our motors. This again is a monotonous process because you have to do each one. And unlike the other builds where we did this as the first thing and then we went on to the main body and soldered everything together, we're doing this as the last thing. And after this, the build is more or less complete because we have all the other connections finished. So just assume that two of these motors are going to be going in the wrong direction when you solder it together. And again, using the self-adhesive tape is nice because you can undo the connection easily and just resolder the connection from the ESCs and then just put the wrapping back on. Again, this is a normal process, and generally it's really hard to tell which way on the first go the ESC needs to be with the wires to get it going the right direction. So be prepared to resolder at least 4 of these wires. So yeah, I'm going to include a diagram down below on the motor direction. So we're also going to take care of the connections going from the power distribution board to the ESCs. We have positive and negative connections next to each ESC for the ESC to solder to. It's very convenient and easy to do. There's also connection for your signal wire from the ESC, and that signal wire can be routed to a different part of the power distribution board and then routed to your flight controller. Now, I like leaving the signal wires on my ESCs, which allows me to flash them later with different BL Heli firmware, and allows me to enable 3D mode and configure 3D mode. So yeah, just keep that in mind when you're building this and putting it together. And if you have any questions, please feel free to leave a comment. I will love to respond and try to help if I can. And again, the diagrams are going to be included in the video description, so please look at those. There's going to be one on the motor direction, and then there's going to be one just for the DragonFly 32 flight controller. There you have it. We're done with that process. We've got our ESCs soldered together and covered up. I lost a lot of footage of wiring all the ESCs to the flight controller, so just use the diagrams in the video description to figure out how to do that part, or watch my last video. So now we're going to connect the receiver wire coming from our flight controller to our DR4 receiver using CPPM. Make sure number 3 and 4 are bridged with the included connector. And we're going to mount that in the middle of our frame. Now, if you're using a battery strap on the middle of your frame, the receiver might be in the way if you put it where I put it. I would recommend maybe moving the receiver to a slightly different spot, but putting the antennas where I have them located. Or what my friends have been doing is running them underneath the frame along the arms. Just keep that in mind while you put this together. And we're getting almost done at this point. We've got a lot of the frame together. All that's left is mounting the final camera, mounting the receiver, and basically buttoning it up. It's generally a good idea to have the receiver wires coming away from the craft. You see the 2 exposed ends? It's only the exposed ends that are actually the antenna. The rest of it is just extra length. And what we're going to do on this build to make the antennas a little bit more durable is use RC car antenna tubing. This stuff is super durable. It'll take a direct prop hit without destroying the antenna. And then we're going to hot glue them in place so when you crash they will not move. And then of course you put on the GoPro mount, which I think is separate, and a battery, and you kind of have the final look of the frame. So cool. So let's get the camera mounted. The camera has a couple of different mounting points. You'll notice that if you match up the frame of the camera with the frame of your quadcopter, there's holes that line up. I'm able to use 2 zip ties on the bottom to secure the camera to the frame, but then I also use zip ties to secure the top of the camera frame to each side of the standoffs. So as you see, we have everything connected. We just have to plug in our video transmitter, and we have our camera already connected, and now we just have to button it up. And this is one of my favorite parts of the process, is when we get to this point. We haven't plugged it in yet. Everything is basically together. It looks like a quadcopter, but it's yet to fly. All the work you've put into it is finally paying off, and you start to see the finished product. At this point, you'll probably want to put on your battery straps, which is something I didn't do in this video. So we're almost done with this process. We have only one thing left to do, and that is hot glue time. So with the hot glue gun, we're going to secure our LED on the back of our quadcopter to the frame. Now you can use something else besides hot glue, because again the LEDs heat up and they could move themselves off the frame. So I would suggest using what's called shoe goo, which is used to keep your shoes together. Cool, and we are done. We just have to configure this quadcopter, which we will do in a different video, which I have something special planned for. Stay tuned for the maiden video and other videos where I test the durability of these antennas and the rest of this quad. I hope you enjoyed watching and found this video helpful. Please leave a comment, like the video, and subscribe for more videos like this and for future flight videos with this quadcopter. And a special thanks to Multirotor Mania for this kit. Go check them out for this and other builds.